Hello again, and welcome to our lecture on human capital. Up till now, we've talked about the quantity of labor supply, but we haven't discussed quality of education. A word that encapsulates the quality of education is called human capital, and it refers to the economic value of the unique set of abilities and skills that a worker has. And people bring many different skills to the job, and also workers continually add to their stock of human capital throughout their lives, not only through formal education, but also through on the job experience. In terms of stylized facts, education is strongly correlated with labor force participation. This makes sense. People who are more educated, since they have a lot more to offer, tend to have much lower, much higher participation rates. They also have much lower unemployment rates. So education is also strongly correlated with unemployment. People who don't have very much education tend to have higher unemployment, and people who are highly educated tend to have low unemployment. And of course, education is strongly correlated with earnings. The more skills you have, you tend to get paid more. So there's a strong positive correlation. Overall, education plays a significant role in improving one's labor market outcomes. So we're going to look at the basic human capital investment model, and we're going to assume that investments in human capital improve productivity and earnings. In a model that we'll learn in the next lecture, we'll see that you could have a correlation between education and earnings, even if there wasn't any productivity enhancement benefits of human capital. But for now, we are saying that investments in human capital are made to improve productivity. Is the investment worthwhile? Well, we would want to obviously do a cost-benefit analysis. Do the benefits outweigh the cost? And that's something we'll be looking at with this model. So the optimal investment in human capital is going to be determined by whether the additional benefits of a year of education exceed the costs. Okay, so we'll be looking at two different concepts, looking at the marginal benefit and marginal cost of education, or we could also look at the rate of return on investment. So we'll look at whether the internal rate of return is higher than, say, the market rate. So the costs of getting human capital or acquiring human capital can be broken down into three different categories: out-of-pocket or direct expenses. These are, of course, things like tuition, the money you spend on books, the money you spend on pens and paper and supplies. Also, though, there's an opportunity cost when you get education, and that's one of the biggest opportunity costs is foregone earnings. When you're in school, you usually don't also work full time, and so you're foregoing earnings. And then another cost would be sort of psychic costs or psychic losses, because education can be often difficult and tedious for some people. It requires effort on your part, and that could be different for different people. So the expected returns to education and training investments are going to be in the form of higher earnings. Okay, so one of the benefits of getting more education is that you can command a higher salary. Another important benefit is increased job satisfaction. So many jobs that, say, require a master's degree or undergraduate degree are going to be much more interesting than jobs that don't require any skills. You will likely have more responsibility and autonomy. You just get a much better satisfaction with your job and your life. As well, if you're more educated, this will allow you to also have a greater appreciation for different non-market activities and interests. Obviously, if you're a very good reader, you learn how to read. Say you get an undergraduate degree in English literature. Well, you can have the abilities to read a whole different array of books and literature. And the more problem-solving skills you've acquired, for example, gives you the ability to take on a greater degree of hobbies. and other things. So there are many benefits to getting educated, not just that it increases your earnings. Okay, so we're looking at sort of like a benchmark model, I guess you could say. The simplifying assumptions are going to be that there's no direct utility or disutility from education. Hours of work are fixed, and income streams associated with education amounts are known. Obviously, in the real world, these would be something you would estimate. And we're also assuming that individuals can borrow and lend at the real interest rate. So there's perfect capital markets. Okay, so let's look at an example. So suppose we have an individual. They can choose to either quit school after high school and receive a wage of WHS, and so their earnings over their lifetime would be WHS. Alternatively, they can go to college, and then their earnings would be much higher at WCOL here. If they decide to go to college, they're going to have to give up a year of earnings between 18 and 22, and they're also going to have to pay some direct costs for education. Okay? So someone who decides, so if this person decides to quit after high school, their earning stream, their total earnings would be given by this box A. Now, somebody who decides to go to college will get earnings equal to D plus A, so this entire box here, but they're going to have to give up a year's salary, B, which is represented by B, and then also pay direct costs, which are represented by C. So it only makes sense to go to college if this area D, which is the extra earnings you get from going to college over your lifetime, exceeds the costs, B and C. Here's another example. So suppose we have a 16-year-old who faces three choices. They could not finish high school and get this income stream A. They could decide to finish high school and get this income stream B. And they could decide to go to university and get this income stream C. Okay? Now, the direct costs of going to university are represented by this area here. And so if we look at this, a person would want to go to university if this additional area here, represented by F, exceeds the costs. And the costs would be B, C, and D. Okay. And again, also for the person who is deciding to finish high school, well, if they decide to finish high school, they're going to have to give up this area A. But then they will get this larger stream. So they'll want to finish high school if the area E is greater than A, which it is in this example. So in order to understand this model, we use present value calculations. You may have seen this before in your other courses. We want to discount money in the future to today. Obviously, an amount of money that you're going to get in the future is going to be worth less than it is now. Okay, and simply that's because you could have invested the money at the market interest rate, and you're also not only the market interest rate, but there's also just a personal discount rate that you could have as well. So with this present value these present value calculations, it allows us to be able to compare dollar amounts spent and received in different time periods. We're able to compare apples with apples, not apples with oranges. So the present value of something, so we're going to denote present value with capital PV, and we're going to say that it's equal to y divided by 1 plus r raised to the t. T is for time, r is the market rate of interest, and the y here is a sum of money. Okay, and so this would be the future value as well. So this, in the future we're going to get this amount of money y, and in the present, in order to get its value, we divide it by 1 plus r to the t. Okay, and again, t is the number of periods, y is the value in the future. R characterizes the market interest rate, but it also incorporates time preferences, how a person feels about giving up consumption today in return for future rewards. So let's look at it in a little more detail. So the future value of something, we're going to call that B1 here. And let's say we're thinking of $100, and let's say the rate R is 5%. So then a year from now, what's that going to be worth? Well, we're going to take the amount that it's worth today, and then we're going to add the interest rate times what it's worth today, which is equal to the amount now times 1 plus R. Okay, so the future value, B1, is equal to what it's worth today times 1 plus R. Okay, and in this example, it would be $105. So let's say we have $100 now, and then the rate is 5%. Well, then the future value of this $100 would be $105. And so we can actually just go backwards. We could say, okay, this $100 here is the present value. So if we just replace that with present value and solve for PV, we'll see that the present value is obtained by taking the future value and dividing it by 1 plus R. So in this case, we'd be back to our $100. Okay, so when R is the market interest rate, so basically R is the market interest rate, and this term here in brackets is called the discount factor. Now let's suppose we're going to get some money 2 years from now. Okay, so what would the future value of it be? We'll call that B2. Well, B2 would be equal to B1, so what it's worth a year from now, plus what it's worth another year. So we're going to take B1 and multiply it by 1 plus R. We're going to, push it forward another year. But we know B1 is equal to B0 times 1 plus R. So if we substitute that in, we get that B2 is equal to B0 times 1 plus R plus B0 times 1 plus R times R. And if we simplify the terms, we get B0 times 1 plus R squared. Okay, so since B2 is equal to B0, 1 plus R squared, we're solving for B0 in this case. If we wanted to get the present value, it would yield this here. Okay, so when we want to bring an amount of money to the present, we divide it by this discount factor, and the squared term refers to the amount of time periods in which the interest rate is applied. Usually we're talking about years. But now suppose we want the present value of, say, some type of an investment. We're assuming it's human capital investments here. Let's say that there are different values in different years. So we could have a value in B1, in the first year of B1, another different value in the second year of B2, and so forth. Well, we would want to calculate the following. We want to take each of those future streams of income and divide them by their corresponding discount rates. So let's think of an 18-year-old high school graduate who's faced with a decision to work or go to college. The present value of the benefits at age 18 over t minus 18 years remaining years of work would be equal to this. So we're saying t would be the time when they stop working. So if we suppose that the amount that they're going to get is the same, so we'll just assume it's some value y, we would calculate this. The present value is equal to y divided by 1 plus r, so that's for the first year. or sorry, in year zero. So right now, if you're talking about this year and they're making the money this year, we don't discount it. So we're just going to divide it by 1. Then next year, we're going to divide it by that, and so on, up to t minus 18 years. Now, there's a way we could estimate this, because this is quite tedious to calculate. There's a way to estimate this, and the way to estimate this is to just we keep the first year, so the year 0 amount, and then all of the rest we can just estimate with this thing here, y divided by r. Okay, so we can estimate this with this. So again, y is some yearly income, r is the discount rate, and t is, capital T is the age at when you would stop working. Okay. So let's now think about the present value of net income with one further year of education. So we're thinking about what's, the value of an extra year of education. So we're going to write that as the present value is equal to the income that you would get if you didn't get another year of education plus the change in the income. And this is usually going to be positive because higher education is going to give you higher earnings. Okay, so your income would be this before any additional education, and we're going to be adding this chunk on as a result of that extra year of education. And we're going to discount that to the present, and then we want to subtract any direct costs of education. Okay, so if we're assuming that we're going to get an extra year of school, this would be next year, which is when we would get our earnings. So if we're thinking about going for another year of schooling now, then our D would be our direct cost to go now, and the additional amount of earnings we would get would be the change in Y. Okay, and so remember, this is an estimate over our whole lifetime, so we would just take that and divide it by R. Okay, so again, the change in income would be the increase in annual income due to that extra year of schooling. So the overall net gain from an additional year of schooling would be obtained by looking at the present value. So PV star is the present value of your lifetime earnings if you were to decide to get that extra year of schooling. And we would want to subtract the present value of your lifetime earnings if you didn't get that extra year of schooling. So this first term is what we have here. Okay, so this is the newer, higher income divided by R, which is the estimate of it over your lifetime that we saw in the previous slide. We subtract the direct cost associated with that additional year, and then we're going to subtract the lifetime earnings if the person didn't get that extra year of schooling. Okay? So again, recall the present value can be estimated with y plus r, or divided by r. Okay, and so if we simplify this, we would get that we have the change in y over r. So that's that additional yearly earnings divided by the discount rate minus y plus d. Now this is the additional benefit. So that's the marginal benefit of an additional year of schooling, right? Because it's how much your income increases over your lifetime. Because we're using that short form, dividing it by r, and we're going to be subtracting off the marginal costs here. So the cost of that additional year of schooling is the foregone earnings for the year plus any direct costs. Okay, so this is the marginal benefit, this is the marginal cost. And so it's optimal, obviously, and remember, in economics we think on the margin, and so we should keep doing something if the marginal benefit of doing it exceeds the marginal cost. And so here we should keep getting schooling as long as the marginal benefit exceeds the marginal cost. Okay, so to maximize the net present value of lifetime earnings, we want to increase education as long as the marginal benefit exceeds the marginal cost. Okay, in other words, we want to keep getting education as long as the present value of the benefits of an additional year equals the present value of the additional costs. We can also state the maximization problem in the form of the internal rate of return. The internal rate of return is essentially what the return on getting an additional year of education is, as long as that exceeds the market rate of interest, which is the opportunity cost of financing the investment. Because you can always, instead of spending money on human capital, you could always just get a certain interest rate at the bank for that money. You could invest it at the market interest rate. And so as long as the internal rate of return exceeds the market rate of interest, you would want to keep getting schooling. So the internal rate of return, just to be a little more clear, it's basically the implicit rate of return earned by an individual acquiring that amount of education. So it's basically an answer to this question: how large could the discount rate be and still render the investment profitable? So the internal rate of return would be the solution to R here for a known cost and benefits. Okay, so it would be the interest rate that would make this break even. Okay, and so that would be the internal rate of return on an investment. And so you'd want to keep investing in education as long as that internal rate of return exceeds the market interest rate. So in a diagram, we have our marginal benefits and marginal costs. So if we're thinking of this in a diagram, we would want to keep getting schooling. So here, E, years of education. We'd want to keep getting schooling until the marginal benefit equals the marginal cost. Now the marginal benefit's going to fall because of diminishing returns to education. So at first, education is going to give you a much larger wage, but you could think of after your second PhD, that's not going to really increase your wages all that much. And in terms of costs, the more years of schooling you get, the costs are going to increase because your earnings, your foregone earnings, are going to be increasing because you're higher educated. And then you can also have direct costs increasing. An example of that would be, of course, elementary school or high school is typically free, but then post-secondary education costs. You have to pay a lot more. And here we have our internal rate of return. So the internal rate of return is going to fall as years of education increases. And that's, again, mainly because of the diminishing returns to education. And the market interest rate is constant. So in this context, we would keep getting schooling as long as the internal rate of return exceeds the years of, the market interest rate. When they're equal, that refers to the optimum. So it's a very simple model, but I mean, obviously we don't make these explicit calculations when we're deciding to go to school, but we implicitly do, and we have expectations about what the salary would be. And so the implications of this theory is, they're actually quite clear, and that's one of the key implications, obviously, is that you should make human capital investments earlier in your life, and most people do, and that's simply because you want a longer time horizon to be able to recuperate those you want to have a long time horizon to be able to enjoy the higher earnings. So when you're older, people would want to enjoy the benefit. When you're older, the period to enjoy any benefits from human capital investments is going to be shorter, and your foregone earnings are also going to be much higher. If you decide to go to school when you're 45, the earnings that you're able to make are likely going to be higher than when you're 18 years old. Okay, so there's less incentive for individuals experiencing discontinuity in the labor force. That's obviously another key implication. So when you take time off from work, there's less incentive for this because that could reduce your earnings. And investment in education and a progressive tax system. So higher taxes means a shift downwards in your income streams. So that would mean that your marginal benefit equaling marginal cost would be at a lower level. So there's in terms of a progressive tax system, there tends to be a lower investment in human capital. So age earning profiles, we've seen these before. We can now see that highly educated workers would earn more than less educated workers, or at least we would speculate that because they're getting some useful skills that should be able to make them more productive. And earnings rise over time at a decreasing rate. So that's another characteristic we will see. And we see that the age earning profiles of different education cohorts will diverge over time. So let's, earnings increase faster for more educated workers. So let's see what these look like. So these are typical age earnings profiles that you will see. So college graduates tend to make a lot more than those who drop out of high school, just finish their high school, or drop out of college and only have some college. Okay, and we can see they're steeper at first for college graduates, and we can clearly see that we have this fanning outward. So high school dropouts, when we look at the data, their earnings don't change all that much. But when you get highly educated, they increase a lot. They don't start tapering out till much later on in life. And the profiles for women are generally similar. Now, let's do some practice questions to make sure we got the concepts. So let's suppose we have Mary. She's an 18-year-old high school graduate who can take a job paying $30,000 without further education. The prevailing interest rate is 5%, and Mary plans to work from age 18 till 65. So if we wanted to calculate the present value of her lifetime earnings, how would we do it? Well, we would take 30,000, so that, in the current year, she's going to make 30,000. Next year, she's going to make 30,000. The year after, 30,000, and so on. And that's going to happen for 47 periods because she's 18 and she's going to retire at age 65. Okay, so when we add all that up, we get $569,430. Okay, so that's the present value of her lifetime earnings. Now suppose she completes a 1-year post-secondary program. If she does that, Mary's going to earn $33,000 per year instead. So to get the present value of that lifetime, we would just we put a 0 for the first year because she's not going to get any earnings. So she's going to forego $30,000 in earnings to go to school. We're assuming here there's no direct costs. And then we do the same, but now the income that she would earn every year is $33,000. So when we do this, calculate everything, we get $593,373. And so obviously that's more. So this extra year of schooling increases the present value of her future income by $23,943. And so we would want to compare these two values. And that, that would be the net present value of going to college over not going to college. Okay, so this question is asking us to compute the internal rate of return using this formula, which is the change in y over y plus d. Okay, if you remember, the internal rate of return is sort of, if you think of an investment stream, it's the interest rate that would make it break even. So here, if there's no direct cost, for Mary, the internal rate of return is just going to be 10%. If she decides to get 1 year of schooling, the internal rate of return is going to be 9%. Okay, and the direct costs have to go up for Mary to not undertake the investment. And right now we were assuming that there wasn't any direct costs. Okay, so we could use this formula to estimate the internal rate of return. It's just that change in earnings. So if you get the extra year of schooling, this is your benefit, and then you're dividing it by what you had to pay or your cost to get that. Usually when you could think of, in general, the return to something is usually what you get divided by what you have to give up to get that. So here, if you do an extra year of schooling, the change in income is this amount, and so that's your benefit, that's what you're going to get. But in order to do that, you had to give up a year of earnings and any direct cost of going to school. Okay, so here, if there were no direct costs, the internal rate of return would be 10%. Obviously, then if there's direct costs, say they're $3,000, that would decrease the internal rate of return, and it would be 9%. So clearly here, the direct costs would have to go up quite a bit more for her not to undertake the investment. If we look at the previous slide, we can remind ourselves that the discount rate for her was 5%. And so here, even with direct costs of $3,000, the internal rate of return is 9%. So we could increase these direct costs by a lot more before the internal rate of return would be 5. Okay? So in fact, the direct costs here would have to go up to $30,000 for the internal rate of return to equal the market interest rate. Okay, here's another question. Calculate the present value of earnings for a discount rate of 10%, 45 time horizons, and per period wages of $10. Assume the person works 5 days a week, 48 weeks a year, and 8 hours per day. Okay, so let's first figure out what the annual earnings would be. So this person in a year is going to work 5 times 48 times 8 hours. Okay, so that's 1920. And if they're getting $10 an hour, then the annual earnings are going to be $19,200. Okay, so in order to calculate the present value of their lifetime earnings, and we could estimate this with our formula from before, we can just calculate it like this. We would do 19,200 plus 19,200 divided by 0.10, and that would equal $211,200. Okay, we have another question. This one's a little more involved. Debbie is about to decide which career path to choose. She has narrowed her options to 2 alternatives. She can become either a marine biologist or a concert pianist. Debbie lives for 2 periods. In the first, she gets an education. In the second, she works in the labor market. So we're simplifying things here. We have 1 period where the person gets education, and then the next period they work. Okay? If Debbie becomes a marine biologist, she will spend $15,000 on education, so that's the direct cost in the first period. If she becomes a marine biologist, she'll make $472,000 in the second period. So that would be her income in the second period. On the other hand, if she becomes a concert pianist, she'll spend $40,000 on education. So the direct cost will be $40,000, and the earnings for being a concert pianist would be $500,000, and she would get that in the second period. So suppose Debbie can lend and borrow money at 5%. So we're going to say our discount rate's 5%. Which career will she choose? Now B is the same question, but they're increasing the discount rate to 15%. Okay, and now we can kind of speculate there. If the discount rate's higher, that means that that second period income is going to be worth less, and the first period's cost would have a higher weight. So if the discount rate is going up, the higher the discount rate, there's going to be some point where the person would not probably find it worthwhile to invest in 40,000 in education to get the extra income associated with the concert pianist. If you look, this is what a concert pianist makes in the second period. This is what a marine biologist makes. So there's this difference here. This 28,000 isn't going to be viewed as beneficial the higher the discount rate. Okay? And in C it says, suppose musical conservatories raise their tuition, so they're going to increase it to 60,000. And if Debbie's discount rate is 5%, which would she choose? So let's see what the answers are. So for A, the present value of lifetime earnings for a marine biologist is going to be equal to negative 15,000. So here you can think of in the first period there's zero income and she has to spend 15,000. Now we're going to add to that the $472,000 that she would make, but we're going to discount it 1 year at the 5% discount rate. So the present value of this is $434,523.81. If she becomes a pianist, we're going to have a negative 40,000 in the first year because that's the direct costs of that education. We have our 500,000 discount rate. That's equal to $436,190. So in this case, the pianist option exceeds the biologist option, and so she would become a concert pianist. Now, if the rate of interest is 15%, and we do the same calculations, we get that the biologist occupation would be better for her. So if the discount rate is increased to 15%, then she would change her decision. Okay? That $500,000 in the second period, isn't as nice as it is when the discount rate is 5%. Okay, lastly, Debbie will compare the present value of being a biologist from part A with the present value of becoming a pianist. So the relevant present values are going to be here. So all we've done here is change this to 60,000. So we've increased the cost of the training for this occupation by 20,000. Discount rate is still 5%, and that increase in cost. So even though in the second period she would get $28,000 more in terms of a salary, paying an extra $20,000 in the first period would, that extra that $28,000 she's going to get extra. So that $8,000 over and above the additional cost isn't, because of the discount rate, going to entice her to want to do it. So here she's going to want to be a biologist when the cost of getting educated as a pianist increases by 20,000 from the 40,000 that it was before. So the cost of as the cost of an investment increases, the chance of pursuing that investment obviously fails. Okay, our next question. Suppose Anna is considering taking a graphic design training program that involves direct costs of $3,000 and foregone earnings of $5,000 in the first year, in year 0. The training program will increase Anna's earnings by $3,000, $4,000, and $5,000 for the 3 years she plans on working. Okay, so her earnings are going to increase by this amount. Now it's asking, what is the net present value of the training program if the discount rate is 10%? Okay, so you might want to pause it, see if you can calculate the answer, and then we'll look at the answer together. So the answer is 6,789, and we get that by doing the following calculation. So we know in year 0, she has to pay out $3,000. Okay, so we're going to discount, we're in year 0, so the discount factor is just going to be 1. And then so if she does that, she's going to get an additional $3,000 in the first year, an additional $4,000 in the second year, and an additional $3,000, or an additional $5,000 in the third year. Okay, so these are just the differences, and so then we know the net present value of that stream that for her to get educated is $6,789. Okay, next question. The opportunity cost of obtaining human capital is, which one of these is correct? Well, the answer is B. So the opportunity cost of getting educated is foregone income. Okay? A is a cost, but these are direct costs, not opportunity costs. If you were to phrase the question as, well, you could think of there is an opportunity cost associated with the money spent on these, but that's not what was asked. We consider these direct costs, books, supplies, tuition fees. And certainly C is not true, and D is not true. Okay, next question. Mary is an 18-year-old high school graduate who can take a job paying $30,000 without further education. The prevailing interest rate is 10%. What is Mary's present value of earning $30,000 a year from age 18 to 20? So 3 years in total. Okay, I'm going to pause it, or you should pause the video, calculate it for yourself, and see what you get. Okay, what did you get? Well, the answer is $82,066. How did we get that? Well, we took $30,000, discounted it. It's year 0, so there's no discount factor. The discount factor is just equal to 1. 30,000 in the second year, we divide by 1.1. 30,000 in the year after, we divide by 1.21. When we sum everything up, we get $82,066. Okay, so same question. So Mary, we're still talking about Mary, but now assume that Mary would earn $60,000 a year if she completes a 1-year post-secondary program. Okay, so in same ages, 18 to 20, so we have 3 years. So now in year 0, so the answer is going to be $82,066. Let's see how we get that. Okay, so the answer is $104,132. How do we get that? Well, in the first year, she's not going to get any income. The question never mentioned any direct costs, so the direct costs are 0. But in the second year, she's going to get $60,000. We discount that by the appropriate discount factor. Same with the next year. When we add everything up, we get $104,132. Okay, next question. The rule for optimal human capital investment is that, which one do you think is true? So maybe pause the video, read them over, and I'll let you know what the answer is in a moment. Okay, the correct answer is A. Okay, so as we said in the beginning of the lecture, an individual should increase their years of schooling, if the discounted present value of the benefits of an additional year of education equals the discounted present value of the additional costs. Okay, well, thank you for listening. In the next lecture, we will continue with our human capital model. We'll also look into a new model called the signaling model. So we'll see you then, and have a great day. Bye now.